Okay, so where have we got up to? Well, let me turn that. Where have we got to? We know that the quantity q that we're interested in is greater than or equal to a third a cubed plus b cubed plus c cubed times a fraction of 3 plus a plus b plus c over 1 plus a, 1 plus b, 1 plus c. Is that cubed? No, that's what that is. But now we need to use the fact that ABC equals 1, because we were given that right in the beginning. So let's have a think about that. Well, let's have a think about this term first. It's a third a cubed plus b cubed plus c cubed. And what I'm going to do is I'm going to force that into being a cubic average. And we know that that's going to be greater than or equal to the linear average, a plus b plus c. Okay, well, we know that. What about a third of a plus b plus c? Well, we know by the AMGM inequality that's greater than or equal to abc to the 1/3 to the power 1/3 equals 1, because we know that abc equals 1. What about this term? 1 plus a, 1 plus b, 1 plus c. Well, again, I'm going to turn it into a geometric mean, and that's going to be less than or equal to the arithmetic mean of these numbers, 1 plus a plus 1 plus b plus 1 plus c. And of course we can simplify that, 1/3 of 3 plus a plus b plus c. So we've got 1, 2, 3 different inequalities, and they're all in the right order. You see, this one's a less than or equal to, but of course that term there is on the bottom, so that's okay. So I'll just go through it one by one. So that's going to be greater than or equal to, and then we'll use the first one. It's going to be a plus b plus c over 3 cubed times 3 plus a plus b plus c over 1 plus a, 1 plus b, 1 plus c. See how I'm not scared to write it out every single step, because it's quite easy to get confused. A plus b plus c over 3 cubed times 6 over 1 plus a, 1 plus b, 1 plus c. Why 6? Because it's 3 plus a plus b plus c, and we know from here that a third a plus b plus c is greater than or equal to 1. So a plus b plus c is greater than or equal to 3, and I'm using that there. Greater than or equal to a plus b plus c over 3 cubed, which I'm just copying, times 6 over, what did we say? Oh, it's here. A third of 3 plus a plus b plus c. It needs to be cubed. 1 plus a, 1 plus b, 1 plus c without the cube is less than or equal to 1/3 of 3 plus a plus b plus c, all cubed. So that cubed has to appear, just scroll right, there. 6 times, the 3's disappear, a plus b plus c over 3 plus a plus b plus c cubed. And we know, that a plus b plus c is greater than or equal to 3 from the AMGM inequality. So I'm going to write a plus b plus c equals, let's say, 3 plus alpha, and alpha is it strict? No, because a equals b equals c equals 1 will satisfy, and then alpha would equal 0, of course. So that equals 6 times a plus b plus c is 3 plus alpha over 6 plus alpha cubed, which is greater than or equal to 6 times a half cubed, because we've got 3 over 6. 3 plus alpha over 6 plus alpha is going to be bigger than a half, which is bigger than or equal to 6/8 equals 3/4. QED. That was a monstrously difficult piece of reasoning. That went on and on and on. You had to have the arithmetic geometric inequality over and over again. You needed Chebyshev's inequality, you needed the rearrangement inequality. The first 2 or even 3 attempts which I made using AMGM, using the rearrangement inequality, and using, what was the other one I did? Can't remember now, but what the other one I did failed. Until we hit upon the right idea of, first of all, ordering A, B, C. We wrote A greater than or equal to B greater than or equal to C, and then observing that the denominators of the original expression were in the same order. And then we used Chebyshev's inequality because the rearrangement inequality wasn't strong enough. And even after we'd done that, there was quite a lot of work. I think this is a very, very challenging question. Anyway, I'm going to stop there. Done.